Hello dear students, in this video I'll continue with the one-shot revision series for the CBSE board exam. In this video we will revise all the concepts from chapter 3b, which is integration and its applications. So first we will see what is integral of a function. Now we are aware that if we have a function, say capital F of x, then the derivative of this function capital F of x, it is nothing but say small f of x. So if we consider the derivative of a function capital F of x as this small f of x, then the integral or the primitive or the antiderivative of f of x with respect to x, this is given by integral f of x dx. This is equal to capital F of x. That is integral of d by dx of this capital F of x. This is equal to capital F of x, which is nothing but integral f of x dx. And now if we have a function where we have to find the derivative as f of x plus some constant, say we have 1.3, or if we have a constant say 5 square, or if we have any constant say c. Again, the derivative of this function, it is also equal to small f of x. So we have integral f of x dx, it is equal to capital F of x plus some constant c. Now this c, it is called the constant of integration. So when we consider the integral of a function given by integral f of x dx equal to capital F of x plus c, then this c, it is called the constant of integration. We have the sign, which is the sign of integral, and then f of x, it is called the integrand. This capital F of x, it is the antiderivative or the primitive of small f of x, and f of x dx is called the element of integration. So these are the various terms associated with the integral of a function. And now we will see the various formula for standard integrals. So integral x raised to n dx, it is x raised to n plus 1 upon n plus 1 plus c. Integral 1 into dx, it is x plus c. Then integral e raised to dx is e raised to x plus c. Then integral a raised to x dx is a raised to x upon log a plus c. Next we have integral 1 by x dx. It is log mod x. And next we have integral 1 by root of x square plus a square dx. It is log mod x plus root of x square plus a square plus c. This is log mod x plus c. And next we have integral 1 by root of x square minus a square dx. It is log mod x plus root of x square minus a square plus c. So these are some of the formula for standard integrals. Now let us continue with some more standard integrals. Next we have integral root of x square plus a square dx. It is equal to x by 2 root of x square plus a square plus a square by 2 log mod x plus root of x square plus a square plus c. Next we have root of x square minus a square dx, integral of this. So this is equal to x by 2 root of x square plus x square minus a square minus a square by 2 log mod x plus root of x square minus a square plus c. Next we have integral 1 by x square minus a square dx. It is 1 by 2a log mod x minus a by x plus a plus c. Next we have integral 1 by a square minus x square dx. It is 1 by 2a log mod a plus x by a minus x plus c. So these are the standard integrals for various functions. Now we will see the examples. Evaluate the following integrals. The first one is integral of x plus 3 into x plus 2 dx. So let us consider x plus 3 into x plus 2, it is nothing but x square plus 3x plus 2x, which is 5x plus 3 into 2, 6. So let I is equal to integral x plus 3 into x plus 2 dx. So this is equal to integral of this function. So it is integral x square plus 5x plus 6 dx. It is integral x square dx plus 5 integral x dx plus 6 integral dx. So we have seen that integral x raised to n dx is x raised to n plus 1 upon n plus 1. So using that, integral x square dx is x raised to 2 plus 1 by 2 plus 1. So it is x cube by 3 plus 5 integral x dx is x raised to 1 plus 1 by 1 plus 1. So it is x square by 2 plus 6 into integral dx is x plus c. So this is the integral of this given function. Next subdivision, we have integral x cube plus 1 upon x square dx. So let us take, let I be the given integral. So this we can write it as x cube by x square plus 1 by x square dx. So this is integral x dx plus integral 1 by x square dx. This 1 by x square is nothing but it is x raised to minus 2. So integral x dx is x square by 2 using this standard integral formula. Then plus integral x raised to minus 2 dx is x raised to minus 2 plus 1 upon minus 2 plus 1. So it is x raised to minus 1 by minus 1, or it is minus 1 by x. So this is minus 1 by x plus c. So this is the integral of this given function. Moving on to the next subdivision, integral of root x plus 1 by root x the whole square. So first let us square the term. Consider root x plus 1 by root x the whole square. It is root x the whole square plus 1 by root x the whole square plus 2 root x into 1 by root x. So this is x plus 1 by x plus 2. So let us take, let I is equal to integral root x plus 1 by root x the whole square dx. So this is nothing but x plus 1 by x plus 2 into dx. So this is integral x dx plus integral 1 by x dx plus 2 integral dx. Integral x dx is nothing but x raised to 1 plus 1 by 1 plus 1. So it is x square by 2 plus integral 1 by x dx is log mod x plus 2 integral dx is 2x plus c. So this is the integral of this given function. Next we have integral 1 by root of x plus a into x plus b dx. So it is difficult to integrate it directly. So let us consider 1 by root of x plus a plus root of x plus b. Let us multiply and divide by root of x plus a minus root of x plus b, so that we can remove this root symbol in the denominator. So this is equal to root of x plus a minus root of x plus b upon root of x plus a the whole square minus root of x plus b the whole square. So root and square will go. So we will have root of x plus a minus root of x plus b upon x plus a minus x minus b. So plus x and minus x will go. So this will be 1 by a minus b into root of x plus a minus root of x plus b. So let us take, let I is equal to integral 1 by root of x plus a plus root of x plus b dx. So this is equal to integral 1 by a minus b into root of x plus a minus root of x plus b dx. Now we can integrate this easily. So 1 by a minus b is common, we can take it outside. Here root of x plus a is nothing but it is x plus a the whole raised to half. And root x plus b is x plus b the whole raised to half. So it is 1 by a minus b into integral x plus a the whole raised to half dx minus integral x plus b the whole raised to half dx. So here again we have to use the same standard integral formula. Integral x raised to n dx is x raised to n plus 1 by n plus 1 plus c. Here n is half. So this is 1 by a minus b into x plus a the whole raised to half plus 1. Half plus 1, it is 1 plus 2 by 2, which is 3 by 2. So it is x plus a the whole raised to 3 by 2 by 3 by 2 minus x plus b the whole raised to 3 by 2 by 3 by 2 plus c. So here 1 by 3 by 2 is common, which can be taken outside. 1 by 3 by 2 is nothing but it is 2 by 3. So this is 2 by 3 into a minus b into x plus a the whole raised to 3 by 2 minus x plus b the whole raised to 3 by 2 plus c. So this is the integral of this given function. And then we have studied about the cost and revenue function and what is marginal cost and marginal revenue function. So if r of x is the revenue function, then the marginal revenue, it is given by the derivative of the revenue function. So here, if the marginal revenue function is given, then we can find the revenue function by integrating this marginal revenue function. So the revenue function r of x, it is given by integral marginal revenue function dx. So this is how we can find the revenue function when the marginal revenue function is given. Now we will see an example on this. The marginal revenue of a company is given by 80 plus 20x plus 3x square, where x is the number of units sold for a period. Find the total revenue function r of x if x is equal to 2. If at x is equal to 2, r of x is 240. So the marginal revenue function is given. So using this, we have to find the total revenue function. So total revenue function r of x equal to integral marginal revenue function dx. So it is integral 80 plus 20x plus 3x square dx. So integral of 80 dx is 80x plus 20 into integral x dx is x square by 2 plus 3 into integral x square dx is x cube by 3 plus the constant of integration c. So the revenue function is given by 80x plus 10x square plus x cube plus c. We are having this constant of integration c. We have to find the value of c using this condition given. At x is equal to 2, r of x is equal to 40. At x equal to 2, r of x equal to 240 implies 240 equal to 80 into 2 plus 10 into 2 square plus 2 cube plus c. So from this we get 240 equal to 160 plus 40 plus 8 plus c. So 240 equal to 208 plus c. So from this we get c as 32. Therefore the revenue function r of x. It is given by 80x plus 10x square plus x cube plus 32. So this is the revenue function. Now moving on, next we have the various methods of integration. So we have different methods of integration. One is integration by substitution, the next one is integration using partial fractions, and the next one is integration by parts. Now we will see what are these one by one. So if the integrand is of the form root of f of x, then the substitution we have to make is, we can put either f of x equal to t or f of x is equal to t square. And next, if the integrand is log x, then we have to put log x is equal to t or x as e raised to t. And next, if the integrand is of the form f of g of x, then we can put g of x is equal to t. And next, if the integrand is of the form f of x the whole raised to m by n, then we have to put f of x as t raised to n. So if we do such substitutions for such integrands, then we can find the integral of the functions quite easily. And next we have, if f of x dx, if it is equal to capital F of x plus c, then integral f of ax plus b into dx, it is nothing but capital F of ax plus b into 1 by a plus c. So here what coefficient of x we have, that we have to divide. If the integrand is of the form f of ax plus b. We'll continue with the examples. Evaluate the following. Integral root of 2x plus 3 dx. So here let us take, let I is equal to integral root of 2x plus 3 is 2x plus 3 the whole raised to half dx. So this is of the form f of ax plus b. Integral f of ax plus b dx. So it is 1 by a capital F of ax plus b plus c. So here integral x raised to half. Integral x raised to half dx is x raised to half plus 1, which is 3 by 2 upon 3 by 2. Here in place of x we are having 2x plus 3. So it is, we have to divide the coefficient of x. It is half into 2x plus 3 the whole raised to 3 by 2 upon 3 by 2 plus c. So this is equal to half into 1 by 3 by 2 is 2 by 3 into 2x plus 3 the whole raised to 3 by 2 plus c. Therefore, the given integral reduces to 1 by 3 into 2x plus 3 the whole raised to 3 by 2 plus c. So this is the integral of this given function. Next we have integral e raised to 4 minus 5x dx. Now we know integral e raised to x dx, it is e raised to x plus c. Here in place of x we are having e raised to 4 minus 5x. So here we have to divide this by the coefficient of x, which is minus 5. So let I equal to integral e raised to 4 minus 5x dx. So this is nothing but e raised to 4 minus 5x divided by minus 5. So it is 1 by minus 5 plus c. So I is equal to minus 1 by 5 e raised to 4 minus 5x plus c. So this is the required integral. Next we have integral ax plus b the whole square dx. So let us take let I equal to ax plus b the whole square dx. We know what is integral x square dx. It is x cube by 3. Integral ax plus b the whole square dx will be ax plus b the whole cube by 3 into 1 by a. That is, we have to divide by the coefficient of x, which is a, plus c. Therefore, I is equal to ax plus b the whole cube divided by 3a plus c. Next, we have integral a raised to x plus a raised to minus x the whole square dx. So here first let us square the term inside. Let I is equal to a raised to x plus a raised to minus x the whole square dx. So it is integral a raised to 2x plus a raised to minus 2x plus 2a raised to x into a raised to minus x dx. So this will be 1. Now integral a raised to x is a raised to x upon log a. Here we have integral a raised to 2x. So here coefficient of x is 2. So this is 1 by 2 into a raised to 2x upon log a. Plus here coefficient of x is minus 2. 1 by minus 2 into a raised to minus 2x upon log a. Here this is 2 into 1. So 2 integral dx is 2x plus c. So this is equal to a raised to 2x by 2 log a minus a raised to minus 2x by 2 log a plus 2x plus c. So this is the integral of this given function. Next question, evaluate the following integrals by the method of substitution. So here we have to use substitution method to find the integral of these functions. So here let us take let I equal to integral x into root of x plus 2 dx. So let us put x plus 2 equal to t. So from this we get dx is equal to dt and x will be t minus 2. So the given integral becomes, in place of x we have to put t minus 2 and in place of x plus 2 we put t into root t. Dx is dt. So this is integral t into root t is t raised to half minus 2 t raised to half dt. So here this is t raised to 1 into t raised to half. So it is t raised to 1 plus half, which is t raised to 3 by 2 minus 2 t raised to half dt. Now we can integrate this. Integral t raised to 3 by 2 dt, it is t raised to 3 by 2 plus 1 by 3 by 2 plus 1. 3 by 2 plus 1 is 3 plus 2 by 2, which is 5 by 2. So it is t raised to 5 by 2 by 5 by 2 minus 2 into t raised to half plus 1. It is 3 by 2 by 3 by 2 plus c. So this is 2 by 5 t raised to 5 by 2 minus 2 into 2 by 3. So it is 4 by 3 t raised to 3 by 2 plus c. Now we have to substitute for t, that is we have taken t as x plus 2, that we have to substitute in the final answer. Therefore, I is equal to 2 by 5 into x plus 2 the whole raised to 5 by 2 minus 4 by 3 into x plus 2 the whole raised to 3 by 2 plus c. So this is the integral of this given function. Now let us do the second subdivision, which is b. Integral x by root of x minus 1 dx. So let us take, let I is equal to integral x by root of x minus 1 dx. So here let us put x minus 1 equal to t, so that dx will be equal to dt and x is equal to t plus 1. So the given integral becomes integral, in place of x we have to put t plus 1 and in place of x minus 1 we put t. Dx is dt. So this is integral t by root t plus 1 by root t dt. So this is nothing but t by root t is t raised to 1 minus half, which is half, plus 1 by root t is t raised to minus half dt. So integral t raised to half dt is t raised to half plus 1, which is 3 by 2 upon 3 by 2, plus t raised to minus half dt is t raised to minus half plus 1, so which is half upon half plus c. So this is 2 by 3 into t we have taken as x minus 1, that we have to substitute here. X minus 1 the whole raised to 3 by 2 plus 2 into, again here we have t, that we have to substitute as x minus 1. 2 into x minus 1 the whole raised to half plus c. So this is the integral of this function. Next example, integral 3 raised to 3 raised to x into 3 raised to x dx. So here we can see that if we make the substitution 3 raised to x as t, then we will be able to find the integral of this function. So let us take, let I equal to integral 3 raised to 3 raised to x into 3 raised to x dx. Now let us put 3 raised to x as t, so that 3 raised to x log 3 dx equal to dt. So here we already have 3 raised to x dx. So from this we get 3 raised to x dx will be 1 by log 3 dt. So I is equal to 1 by log 3 into integral. Here we have 3 raised to 3 raised to x. For this 3 raised to x we can put t. 3 raised to t, and for this 3 raised to x dx we can put 1 by log 3 dt, 1 by log 3 is outside, into dt. Now it is easy. Integral 3 raised to t dt, it is nothing but 3 raised to t upon log 3 plus c. So I is equal to 1 by log 3 the whole square into, here we have 3 raised to t, t we have taken as 3 raised to x. So it is 1 by log 3 the whole square into 3 raised to x plus c. So this is the integral of this given function. Moving on to the next question. Evaluate integral 1 by root of 9 plus 4x square dx. So here let us take, let I is equal to integral dx by root of 9, we can write it as 3 square plus 4x square, we can write it as 2x the whole square. So here this is of the form integral dx by root of x square plus a square. So integral dx by root of x square plus a square. This is nothing but log mod x plus root of x square plus a square plus c. But here in place of x we have 2x, and in place of a we have 3. So here, since the coefficient of x is 2, we have to divide by 2. So this is equal to 1 by 2 into log mod. In place of x we have 2x plus root of 3 square plus 2x the whole square plus c. This is because since integral dx by root of x square plus a square equal to log mod x plus root of x square plus a square plus c, using this standard result. So this is equal to half into log mod 2x plus root of 9 plus 4x square plus c. So this is the given integral. Next we have integral 1 by root of 5 plus 4x plus x square dx. So when we have questions of this type, we have to complete the squares. So let us take this as equal to I. Now consider 5 plus 4x plus x square. So this is equal to x square plus 4x. If we add and subtract 4, then we will get x plus 2 the whole square. So plus 4 minus 4, and here we are already having 5 plus 5. So this is nothing but x plus 2 the whole square, and here we have 5 minus 4, which is 1 plus 1. So the given integral becomes integral 1 by root of x plus 2 the whole square plus 1, we can write it as 1 square dx. So again it is of the form integral dx by root of x square plus a square, where x is x plus 2 and a is 1. So this is equal to log mod x plus 2 plus root of x plus 2 the whole square plus 1 square plus c. Again it is using the same result. So this is equal to log mod x plus 2 plus this root of x plus 2 the whole square plus 1 square is nothing but x square plus 4x plus 5. This is x square plus 4x plus 5 plus c. So this is the integral of this given function. Moving on, and we have studied about the cost function and the marginal cost function. The marginal cost function, it is given by the derivative of the cost function. Now when the marginal cost function is given, we can find the cost function as integral of marginal cost function dx, where MC is the marginal cost. Now we'll see an example using this. The weekly marginal cost of producing X pairs of tennis shoes is given by marginal cost equal to 17 plus 200 by X plus 1, where C of X is the cost in rupees. If the fixed cost are rupees 2000 per day, find the cost function. So here they have given the fixed cost as rupees 2000 per day. The meaning is that when X is 0, the cost is 2000. They have given the marginal cost. Using this, we have to find the total cost function. So marginal cost is given by 17 plus 200 by x plus 1. So the total cost function C of x is integral marginal cost into dx, or it is integral 17 plus 200 by x plus 1 dx. Now 17 integral dx is 17x plus 200 into integral dx by x plus 1 is log mod x plus 1 plus c. So this is the total cost function. Here they have given fixed cost is rupees 2000 per day. When x equal to 0, C of x is equal to 2000. Implies 2000 equal to 17 into 0 plus 200 into log 0 plus 1 is log 1 plus c. So this is 0, log 1 is 0. So from this we get c as 2000. Therefore, the total cost function it is given by 17x plus 200 into log mod x plus 1 plus 2000. So this is the total cost function. Next we have the next topic, which is integration by partial fractions. So a rational function is defined as the ratio of two polynomials in the form p of x upon q of x, where p of x and q of x are polynomials in x and q of x is not equal to 0. Now when the degree of p of x, if it is less than the degree of q of x, say for example if we have x upon x square plus 3x plus 2, here the degree in the numerator is 1 and in the denominator it is 2, then such functions are called proper rational functions. On the other hand, if the degree of p of x is more than the degree of q of x, say for example if we have x raised to 4 plus 3x square plus 2 upon x square plus 1. Here we can see that the degree in the numerator is 4 and in the denominator is 2. Then such a function is called an improper rational function. When we have to integrate such functions of the form p of x by q of x, it is easy to integrate only when they are proper rational functions. That is only when the degree of numerator is less than the degree of denominator. If the degree of numerator is more than the degree of denominator, we have to perform long division method and we have to reduce p of x upon q of x as q of x into t of x plus r of x upon q of x. So when we divide this p of x by q of x, then this p of x will be nothing but q of x into the quotient plus the remainder. So this, when we simplify, we get it as t of x plus r of x by q of x. Now we can integrate this easily, and here when we consider this r of x by q of x, here the degree of r of x will obviously be less than the degree of q of x, and we can integrate this function also without difficulty. So this is how we have to go about when we have to integrate functions of the form p of x by q of x. Next we have the next example. Identify the following expressions as rational functions. Further classify them as proper or improper. If improper, express them as sum of polynomial and proper rational function. So here the first subdivision is 1 by minus 3x square plus 4x minus 5. So numerator, it is constant function. It is also a polynomial function with degree 0. So here the degree of the numerator is 0 and in the denominator it is 2. So it is a proper rational function. Now let us move on to the next one, which is b. Numerator we have root x. So it is x raised to half. It is not a polynomial function. So this entire function, it is not a rational function. B, not a rational function. Next we have the third subdivision, which is d. Numerator we have x plus 1 into x plus 2. Denominator we have x plus 3 into x plus 4. So first let us simplify and find the degree of numerator and the denominator. So this is x square plus x plus 2x, which is 3x plus 2 upon x square, plus 3x plus 4x is 7x plus 12. So here the degree of numerator and the denominator are the same. Therefore, it is an improper rational function. Only when the degree in the numerator is less than the degree in the denominator, then we call it as a proper rational function. This is an improper rational function. So to make it a sum of a polynomial and a proper rational function, we can perform long division method. So x square plus 3x plus 2 divided by x square plus 7x plus 12. One time will be x square plus 7x plus 12. Here we subtract. So this will become 0. Here 3 minus 7x is minus 4x and 2 minus 12 is minus 10. So let us take this as f of x. So f of x becomes 1 plus minus 4x minus 10 upon x square plus 7x plus 12. Now here we can see that we have expressed this as sum of a polynomial and a proper rational function. This is a proper rational function because the degree in the numerator is 1 and in the denominator it is 2. Another easy method to do this is, without long division, we can do f of x as x square plus 3x plus 2. Here we need x square plus 7x plus 12. So we add and subtract 7x plus 12. Now we take these three terms together. So this will be x square plus 7x plus 12. Here it is 3x minus 7x, which is minus 4x. And here it is plus 2 minus 12, minus 10, divided by x square plus 7x plus 12. So this will be again 1 plus minus 4x minus 10 upon x square plus 7x plus 12. So we get the same answer. Only thing is we can save time by not performing long division. So this is another way of writing the given improper rational function as sum of polynomial and a proper rational function. We can do this only when the degrees are equal. And now let us see integration by partial fractions. So if the rational function, if it is of the form px plus q upon x plus a into x plus b, then the corresponding partial fraction decomposition is given by a by x plus a plus b by x plus b. And next we have, if the rational function is of the form px square plus qx plus c upon x plus a into x plus b into x plus c, then the corresponding partial fraction decomposition is a by x plus a plus b by x plus b plus c by x plus c. And next, if we have px plus q by x plus a the whole square, then the partial fraction decomposition is a by x plus a plus b by x plus a the whole square. Next, if we have px square plus qx plus c upon x plus a into x plus b the whole square, then we have a by x plus a plus b by x plus b plus c by x plus b the whole square. And next, if we have px square plus qx plus c upon x plus a into x square plus b, then we have a by x plus a plus bx plus c by x square plus b. So these are the various partial fraction decomposition for different types of rational functions. And now we have the example question. Express the following as sum of two or more partial fractions and hence integrate. So first we have a 1 by x minus 1 into x plus 3. So let 1 by x minus 1 into x plus 3 as a by x minus 1 plus b by x plus 3. So from this we get 1 by x minus 1 into x plus 3 as a into x plus 3 plus b into x minus 1 upon x minus 1 into x plus 3. So the denominator will go. So from this we have 1 is equal to, here it is ax plus 3a plus bx minus b, or it is a plus b into x plus 3a minus b. So here we can equate the coefficient of x and the constant terms on both sides. Equating coefficient of x and constant terms. So we get in the left hand side coefficient of x is 0, right hand side it is a plus b. In the left hand side the constant term is 1, right hand side it is 3a minus b. Now if we solve these two, we will get a and b. So from this we get 4a equal to 1 or a equal to 1 by 4 and b equal to minus 1 by 4. So now we can integrate this easily. If we have like this directly, it is difficult to integrate, but if we have integral of the form integral 1 by x minus 1 into x minus x plus 3 dx, this is nothing but integral 1 by 4 into 1 by x minus 1 minus 1 by 4 into 1 by x plus 3 dx. So this part we can write it as a by x minus 1, or it is a is nothing but 1 by 4. So it is 1 by 4 into 1 by x minus 1 plus b by x plus 3. So b we got it as minus 1 by 4. So this is minus 1 by 4 into 1 by x plus 3 into dx. Now we can integrate this. This is 1 by 4 into integral dx by x minus 1 is log mod x minus 1 minus 1 by 4 into integral dx by x plus 3 is log mod x plus 3 plus c. Or 1 by 4 is common, which can be taken outside. It is of the form log a minus log b. So it is 1 by 4 into log mod x minus 1 by x plus 3 plus c. This is the integral of this function. Next we have the next subdivision, 3x minus 2 upon x plus 1 into x minus 2 the whole square. So the b part, so here let us take, let 3x minus 2 upon x plus 1 into x minus 2 the whole square. Here the corresponding partial fraction decomposition will be a by x plus 1 plus b by x minus 2 plus c by x minus 2 the whole square. So from this we get 3x minus 2 upon x plus 1 into x minus 2 the whole square equal to, here the LCM will be x plus 1 into x minus 2 the whole square. Here we will have a into x minus 2 the whole square, then b into x plus 1 into x minus 2 plus c into x plus 1. So here the denominator will go. The numerator becomes 3x minus 2 equal to, here a into x square minus 4x plus 4 plus b into x square minus x minus 2 plus c into x plus 1. So here the coefficient of x square is a plus b on the right hand side, and the coefficient of x is minus 4a minus b plus c, and the constant term is 4a minus 2b plus c. Right hand side we have 3x minus 2. Now we can equate the coefficients of x square, x and constant terms on both sides. Equating coefficient of x square x and constant terms on both sides. So here in the left hand side coefficient of x square is 0, right hand side coefficient of x square is a plus b, then in the left hand side coefficient of x is 3, and on the right hand side coefficient of x is minus 4a minus b plus c, and the constant term on the left hand side is minus 2. On the right hand side it is 4a minus 2b plus c. So from here let us have a as minus b. So from here we will have minus 4 into minus b is, it is plus 4b, plus 4b minus b is 3b, 3b plus c equal to 3, and from here we will have, here minus 4a minus 2b is minus 6b plus c equal to minus 2. So here we have the two equations in b and c. If we solve we will get b and c. So here 3b minus of minus 6b will be 9b. 9b will be, here c minus c will be 0. This is equal to 3 plus 2 5. So b is 5 by 9. We have a as minus b. So a is minus 5 by 9. A equal to minus 5 by 9. B equal to 5 by 9. And c equal to, c from here 3b plus c equal to 3. So here 3 into 5 by 9 plus c equal to 3, or c equal to 3 minus 5 by 3. So it is 4 by 3. So we get the values of a, b and c as minus 5 by 9, 5 by 9 and 4 by 3. So we get the values of a, b and c. So here this 3x minus 2 upon x plus 1 into x minus 2 the whole square. It will be minus 5 by 9 into 1 by x plus 1 plus 5 by 9 into 1 by x minus 2 plus 4 by 3 into 1 by x minus 2 the whole square. And now we can integrate both sides. Let me continue here. Integral 3x minus 2 upon x plus 1 into x minus 2 the whole square. This is equal to minus 5 by 9 integral of 1 by x minus 1 plus 5 by 9 1 by x minus 2. This is the b part. A we have completed. Then plus 4 by 3 into 1 by x minus 2 the whole square dx. So this is minus 5 by 9 into log mod x minus 1 plus 5 by 9 log mod x minus 2. Here we have integral 1 by x minus 2 the whole square. So it is nothing but integral x minus 2 the whole raised to minus 2 into dx. So it is x minus 2 the whole raised to minus 2 plus 1 upon minus 2 plus 1. So it is minus 1 by x minus 2. So this is x minus 2 the whole raised to minus 1 by minus 1, which is minus 1 by x minus 2. So this is minus 4 by 3 into 1 by x minus 2 plus c. So this is the integral of this function. Next we have the next subdivision, which is the c subdivision. So here we have x minus 1 into x minus 2 upon x minus 3 into x minus 4. So this is nothing but x square minus 3x plus 2 upon x square minus 7x plus 12. So here we have x square minus 7x plus 12, and here we can see that this is an improper rational function. So to make it a proper rational function, we have to perform long division. Now instead of performing long division, what we can do is, let us add and subtract minus 7x plus 12. It will not make a change. So here we will have, let us take these terms separately. X square minus 7x plus 12, and here we have minus 3x plus 7x, which is plus 4x, and then plus 2 minus 12 minus 10 divided by x square minus 7x plus 12. So we will get 1 plus 4x minus 10 upon x square minus 7x plus 12. So this is nothing but 1 plus 4x minus 10 upon x square minus 7x plus 12 is nothing but x minus 3 into x minus 4. X minus 3 into x minus 4. So here we are having an improper rational function. We are writing it as sum of a polynomial and a proper rational function. Now we can find the partial fraction decomposition for this proper rational function. So let me continue here. We got x minus 1 into x minus 2 upon x minus 3 into x minus 4 as 1 plus 4x minus 10 upon x minus 3 into x minus 4. So for this, let us find the partial fraction decomposition. Let 4x minus 10 upon x minus 3 into x minus 4 equal to a by x minus 3 plus b by x minus 4. So here the numerator becomes 4x minus 10 equal to a into x minus 4 plus b into x minus 3. When we take LCM, the denominator will get cancelled. So this is a plus b into x minus 4a minus 3b. So we can equate the coefficient of x and the constant terms on both sides. Equating coefficient of x and constant terms on both sides. So we get a plus b equal to 4 and minus 4a minus 3b equal to minus 10. So if we multiply by 4, we get 4a plus 4b equal to 16. When we add these two, we will get 4a minus 4a will go, 4b minus 3b is b equal to 16 minus 10, which is 6. And from here a plus b is 4, b we got 6. So a will be 4 minus 6, which is minus 2. So we get a as minus 2 and b as 6. Therefore 4x minus 10 upon x minus 3 into x minus 4. It is minus 2 by x minus 3 plus 6 by x minus 4. So now let us integrate this. Let I equal to integral x minus 1 into x minus 2 upon x minus 3 into x minus 4 dx. This is equal to integral 1 plus, this is 1 plus. For this rational function, we got this partial fraction decomposition. So it is minus 2 by x minus 3 plus 6 by x minus 4 dx. So integral dx is x, minus 2 integral dx by x minus 3 is log mod x minus 3 plus 6 integral dx by x minus 4 is log mod x minus 4 plus c. So this is the integral of this given function. And next let us move on to the next method of integration, which is integration by parts. If we have to integrate a function of the form integral f of x into g of x dx, if we are having a function of this form and if we are not able to do either integration by substitution or integration by partial fractions, then we can use integration by parts. Here we have to take one function as the first function and the other function as the second function. And now we will see what determines which function to take as first and which function to take as second. So we have to take it in the order of the function given by ILATE, pronounced as ILATE. Here I stands for inverse trigonometric functions, L stands for logarithmic functions, A stands for algebraic functions, then T stands for trigonometric functions, and E stands for exponential functions. So here we have to take the first function. If we are taking the first function as f of x and the second function as g of x according to this order, and if we are integrating, we can integrate this as, this is equal to first function into integral of the second function minus integral derivative of the first function into integral of the second function plus c. So this is how we have to go about if we are using integration by parts, and when we have to integrate functions of this type, that is integral f of x into g of x into dx. Now which function we can take as first and which function we can take as second, a rough idea is given by this order. Now using this integration by parts, we have another result. If we have a function of the form integral e raised to x into f of x plus f dash of x into dx, then here this is nothing but e raised to x into f of x plus c. So this is another result which we can use if we are having a function of the form integral e raised to x into f of x plus f dash of x into dx. This is nothing but e raised to x into f of x plus c. Now let us continue with the examples. Next we have example 9. Integrate the following. First we have x into e raised to 2x. So here let us take, let I is equal to integral x into e raised to 2x dx. So here according to the order ILATE, the first function we have to take as the algebraic function and the next function as the exponential function. So this is first function into integral of the second function minus derivative of the first function, that is derivative of x into integral of second function dx plus c. So here integral e raised to 2x dx is e raised to 2x by 2 minus, here derivative of x is 1, integral e raised to 2x is e raised to 2x by 2 dx plus c. Now we can integrate this. So this is x e raised to 2x by 2 minus half into, here we have half into integral e raised to 2x dx. So it is e raised to 2x by 2 plus c. So this is x e raised to 2x by 2 minus e raised to 2x by 4 plus c. So this is the integral of this function. Next we have log x. So let us take let I equal to integral log x dx. This log x is nothing but it is 1 into log x. So here according to this order, we can take log x as the first function and the constant 1 as the second function. So this is log x into integral 1 into dx minus integral derivative of the first function. Derivative of log x into integral 1 into dx plus c. So this is log x into integral dx is x minus derivative of log x is 1 by x into integral dx is x dx plus c. So here this x will go. So here we have x log x minus integral dx is x plus c. So I is equal to x into log x minus 1 plus c. So this is the integral of log x. Next we have evaluate integral e raised to x into x square plus 2x dx. So we have already seen if we have e raised to x into f of x plus f dash of x dx, this is nothing but e raised to x into f of x plus c. So here this is equal to e raised to x into x square plus c. Since f of x equal to x square, f dash of x equal to 2x and integral e raised to x f of x plus f dash of x dx equal to e raised to x into f of x plus c. So because of this, we have the answer for this integral as e raised to x into x square plus c. Next we have integral e raised to x into log x plus 1 by x dx. Again it is of the same form. E raised to x into f of x here is log x and f dash of x is 1 by x. So this is nothing but e raised to x into log x. Here f of x equal to log x and f dash of x equal to 1 by x. Therefore, integral e raised to x into log x plus 1 by x dx, it is equal to e raised to x log x plus c. Since integral e raised to x into f of x plus f dash of x dx, it is equal to e raised to x f of x plus c. So using this, we can write this integral as e raised to x into log x plus c. Next question, integral e raised to x into x minus 1 upon x square dx. So here let us take let I is equal to integral e raised to x into x minus 1 upon x square dx. So this is e raised to x into, here we have x by x square minus 1 by x square dx. So x by x square is 1 by x minus 1 by x square dx. So here f of x is equal to 1 by x and f dash of x is equal to minus 1 by x square. Therefore, I is equal to e raised to x into f of x plus c. Since integral e raised to x into f of x plus f dash of x dx equal to e raised to x into f of x plus c. Because of this, we can write this as e raised to x upon x plus c. Next we have the next subdivision, integral 1 by log x minus 1 by log x the whole square dx. So here let us take this as equal to I. Now let us put log x is equal to t. So from this we get x as e raised to t and dx will be e raised to t dt. So we can put log x as t here and dx as e raised to t dt. So I becomes integral 1 by t minus 1 by t square into e raised to t dt. So this is of the form this same type. In place of x we have t. So it is e raised to t by t plus c. Since integral e raised to t into f of t plus f dash of t dt equal to e raised to t into f of t plus c. Now we can substitute for t. T we have taken as log x. So it is e raised to log x upon log x plus c. E raised to log x is nothing but it is x. So this is x upon log x plus c. So this is the integral of this given function. Next we have the definite integral. So if we have an integral of this form, integral a to b f of x dx, then such an integral is called a definite integral. On the other hand, if we have integral f of x dx, then such integrals are called indefinite integrals. So here if we have an integral of this form, here a is called the lower limit of the integral and b is called the upper limit of the integral. Now what is the meaning of this integral a to b f of x dx? Say for example, if we have this point as x is equal to a and this point as x is equal to b, and this is the curve y equal to f of x. This integral a to b f of x dx, it is nothing but it is the area between the x-axis, the ordinates x is equal to a, x is equal to b, and the curve y equal to f of x. So integral a to b f of x dx, it is nothing but the area bounded by this region. So this is the meaning of definite integral. Next we have the area function. So here if we consider any point say x in this closed interval a comma b, that is x belong to closed interval a comma b, then the area function a of x, it is given by a of x is equal to integral a to x f of x dx, where a less than or equal to x less than or equal to b. So this is the area function. Next we have the first fundamental theorem and the second fundamental theorem of integral calculus. So the first fundamental theorem is that let f be a continuous function on the closed interval a comma b and let a of x be the area function. Then we saw a of x as integral a to x f of x dx. So here the first fundamental theorem states that a dash of x, it will be equal to f of x for all x belongs to open interval a comma b. So this is the first fundamental theorem of integral calculus. Next we have the second fundamental theorem of integral calculus. It states that let f be continuous function defined on the closed interval a comma b and f of x be the antiderivative of this function f. Then we have integral a to b f of x dx. It is equal to the antiderivative with the limits a to b. This is nothing but f of b minus f of a. This is the second fundamental theorem of integral calculus. Now we will see some questions where we have to evaluate the definite integral. So the first subdivision, integral 0 to 3 x cube dx. So A is, let us take let I equal to integral 0 to 3 x cube dx. Here we have to use the standard integrals or the various methods of integration and find the integral of this function, then substitute the limits. So we know integral x cube dx is x raised to 4 by 4 with the limits 0 to 3. So this is 3 raised to 4 by 4 minus 0 by 4. So this is 81 by 4. This is the value of this given integral. Next subdivision is integral 0 to 1 by root of 1 plus x square dx. The B part, let us take let I equal to the given integral. Now we know what is integral dx by root of x square plus a square. It is log mod x plus root of x square plus a square with the limits 0 to 1. So here when we substitute the upper limit, we get log of 1 plus root of 1 plus 1 square minus log of 0 plus 1. So this is log 1 which is 0. Here we have log 1 plus root 2. So this is the value of the given integral. Let us move on to the next subdivision. C part, let us take let I equal to integral 0 to 4 x by x plus 1 into x plus 4 dx. So here we can integrate this using partial fractions. So let us take let x upon x plus 1 into x plus 4 equal to a by x plus 1 plus b by x plus 4. So from this we get x is equal to a into x plus 4 plus b into x plus 1, or this is a plus b into x plus 4a plus b. Now we can equate the coefficient of xn constant term on both sides. So when we equate, we get a plus b equal to 1 and 4a plus b equal to 0. Now when we solve these two, we can subtract this. So we get minus 3a equal to 1 or a equal to minus 1 by 3. Here a plus b equal to 1. So from here we have b equal to 1 minus a. So it is 1 plus 1 by 3, which is 4 by 3. So we get a as minus 1 by 3 and b as 4 by 3. So this we can substitute for a and b and we can integrate. I is equal to integral 1 to 4 minus 1 by 3 into 1 by x plus 1 plus 4 by 3 into 1 by x plus 4 dx. So this is minus 1 by 3 into log mod x plus 1 plus 4 by 3 into log mod x plus 4 with the limits 1 to 4. So first we substitute the upper limit, that is we substitute x as 4, then minus we substitute x as 1. So it is minus 1 by 3. Log of 4 plus 1 is 5 plus 4 by 3. Log of 4 plus 4 is 8. Then minus 1 by 3. Log 1 plus 1 is log 2 plus 4 by 3. Log 4 plus 1 is log 5. So here minus 1 by 3 is common. Let us take it outside. It is minus 1 by 3 into log 5 minus log 2. Then plus 4 by 3 into log 8 minus log 5. So this is minus 1 by 3 into log a minus log b is log a by b. So it is log 5 by 2 plus 4 by 3 into log 8 by 5. So this is the value of the given definite integral. Moving on, next subdivision, D subdivision. So here let us take let I equal to the given integral 0 to 2 x square plus 4. So this is nothing but 0 to 2 root of x square plus 2 square dx. So this is of the form integral root of x square plus a square. So it is x by 2 root of x square plus a square by 2 log mod x plus root of x square plus a square with the limits 0 to 2. So here when we substitute the upper limit, we get x as here 2 by 2 is 1, root of 2 square plus 2 square. So it is root 8 plus log mod. Here when we substitute x as 2, we get 2 plus root of 2 square plus 2 square. So it is 2 plus root 8 minus lower limit is 0. So here it will be 0 minus 2 into here there is 1 2 log of 0 plus root of 0 plus 2 square. So it is log 2. So this is root 8 plus 2 into log of 2 plus root 8 is 2 root 2 minus 2 log 2. So this is root 8 plus 2 into log of 2 into 1 plus root 2 minus 2 log 2. So here this is of the form log of AB, it is log A plus log B. So it is 2 log 2 plus 2 log 1 plus root 2 minus 2 log 2. So plus 2 log 2 minus 2 log 2 will go. Therefore I is equal to root 8 is 2 root 2. 2 root 2 plus 2 log of 1 plus root 2. So this is the value of this given integral. Next we have the next subdivision, integral 0 to 1 x e raised to x dx. That is the e part. So let us take let I equal to this given integral. So here we have to integrate this using partial fractions. So using isolate, here x will be the first function and e raised to x will be the second function. So I will be first function into integral of the second function minus integral derivative of the first function into integral of the second function with the limits 0 to 1. 0 to 1. So this is x e raised to x with the limit 0 to 1 minus here we have integral e raised to x. So integral e raised to x is e raised to x with the limit 0 to 1. So this is 1 into e raised to 1 minus 0 minus e raised to 1 plus 1. So e minus e will go. The value of this is equal to 1. So the value of integral 0 to 1 x into e raised to x dx is equal to 1. Next subdivision, the f part. Let us take let I equal to integral 5 to 3 x square upon x minus 1 into x minus 2 dx. So here we can see that it is an improper rational function. So let us make it as a proper rational function. Consider x square upon x minus 1 into x minus 2. So it is x square upon x square minus 3x plus 2. Let me subtract and add 3x plus 2. So that we can have this together and 3x plus 2 separately. Even if we perform long division, we will get 3x minus 2 as the remainder. So this will be 1 plus 3x minus 2 upon x square minus 3x minus 2. I am sorry, 3x plus 2. So this is 1 plus 3x minus 2 upon x minus 1 into x minus 2. And now we have got a proper rational function. Now we can use partial fractions. So let us take let 3x minus 2 upon x minus 1 into x minus 2 equal to a by x minus 1 plus b by x minus 2. So from this we get 3x minus 2 equal to a into x minus 2 plus b into x minus 1. Or from this we get a plus b into x minus 2a minus b. Left hand side we have 3x minus 2. So we can equate coefficient of x and constant terms on both sides. So we get 3 equal to a plus b and minus 2 equal to minus 2a minus b. Here if we add these two, we get b minus b 0. So a minus 2a as minus a and 3 minus 2 as 1. Implies minus a equal to 1 or a equal to minus 1 and b equal to 3 equal to minus 1 plus b. So b will be 3 plus 1, 4. I is equal to integral 3 to 5 1 minus 1 by x minus 1. Here a is minus 1. So it is minus 1 by x minus 1 plus b is 4 plus 4 by x minus 2 dx. Now integral dx is x. Integral dx by x minus 1 is log mod x minus 1 plus integral dx by x minus 2 is log mod x minus 2 with the limits 3 to 5. So this is 5 minus log 5 minus 1 is 4 plus 4 log mod 5 minus 2 is 3 minus lower limit. When we substitute x as 3, we get minus 3 minus, here we have log 3 minus 1 is 2 minus 4 into log 3 minus 2 is 1. This will become 0. So here 5 minus 3 is 2 and here it is minus log 4 plus log 2. So it is minus log of 4 by 2 plus 4 log 3. So this is 2 minus log 2 plus 4 log 3. This is the value of this given integral. So this is this f subdivision. And next let us move on to evaluation of definite integrals by substitution. So here we have to evaluate the following integrals. The first subdivision is integral minus 1 to 1 x square into root of x cube plus 1 dx. So first let us take let I equal to the given integral. So here we can see that we can make the substitution x cube plus 1 as t, so that x square dx will be 1 by 3 dt. So let us put x cube plus 1 equal to t. So from this we get 3x square dx is equal to dt, or x square dx equal to dt by 3. And at the same time we can also change the limits. So here the lower limit is, it is minus 1. So when x equal to minus 1, t equal to x cube plus 1. So it is minus 1 the whole cube, which is minus 1, plus 1, 0. And when x is equal to 1, t equal to 1 cube plus 1, which is 2. As a result, the given integral becomes integral 0 to 2. In place of x cube plus 1 we have t, so root t, and in place of x square dx we have dt by 3 into 1 by 3 dt. So 1 by 3 we can take it outside. Integral root dt is t raised to half plus 1 by half plus 1. So it is t raised to 3 by 2 by 3 by 2 with the limits 0 to 2. So here it is 1 by 3 by 2, which is 2 by 3. So this is 2 by 3 into 3, 9. When we substitute the upper limit, it is 2 raised to 3 by 2 minus lower limit is 0. So this is 2 by 9 into, here it is nothing but root of 2 cube, or it is root of 2 square into 2, which is 2 root 2 into 2 root 2. So this is 4 root 2 by 9. So the value of the given definite integral is 4 root 2 by 9. Next we have the next subdivision, integral minus 3 to 0 x into root of x plus 4 dx. So let us take the given integral as I, and let us put t equal to x plus 4, so that dt will be dx. Now let us change the limits. When x equal to minus 3, t equal to minus 3 plus 4, so it is 1. And when x equal to 0, t equal to 0 plus 4, which is 4. So the given integral becomes integral 1 to 4. In place of x we can write t minus 4. T minus 4 into root of x plus 4 is root t dt. So this is integral 1 to 4. Now let us multiply t into root t. So t into root t is t raised to 1 into t raised to half. So it is t raised to 3 by 2. So here it is 3 raised to t raised to 3 by 2 minus 4 t raised to half dt. Now integral t raised to 3 by 2 is t raised to 3 by 2 plus 1 by 3 by 2 plus 1. So 3 by 2 plus 1 is 5 by 2. So t raised to 5 by 2 upon 5 by 2 minus 4 into integral t raised to half dt is t raised to half plus 1 by half plus 1. So it is t raised to 3 by 2 by 3 by 2 with the limits 1 to 4. So this is equal to 2 by 5 into 4 raised to 5 by 2 minus 4 into 2 by 3. So 8 by 3 into 4 raised to 3 by 2. Then minus, here we have the lower limit. So it is 1 by 5 by 2, which is 2 by 5, minus here 4 into 1 by 2 by 3. So it is 8 by 3. So here we have 4 raised to 5 by 2. It is root 4 the whole raised to 5. So it is 2 raised to 5, which is 32. And here we have 4 raised to 3 by 2. It is root 4 the whole cube, which is 2 cube 8. So this is 2 by 5 into 32 minus 8 by 3 into 8 minus 2 by 5 plus 8 by 3. So here it is 64 minus 2, so it is 62 by 5. Then here we have minus 64 plus 8. So it is minus 56 by 3. So this, when we take LCM and simplify, we get it as minus 94 by 15. Therefore, I equal to minus 94 by 15. So the value of this given integral is minus 94 by 15. Now let us move on to the properties of definite integral. So the first property is the value of the definite integral, it is independent of the variable. So integral a to b f of x dx is equal to integral a to b f of t dt. This is the first property. Then the second property is integral a to b f of x dx. It is equal to minus integral b to a f of x dx. So if we change the limits, that is if the lower limit becomes the upper limit and the upper limit becomes the lower limit, then the value of the definite integral, that is the sign of the definite integral, changes. Next we have the next property. Integral a to b f of x dx, it is equal to integral a to c f of x dx plus integral c to b f of x dx. So if c is any point in the open interval a comma b, then we can write integral a to b f of x dx as integral a to c f of x dx plus integral c to b f of x dx. Now this property is very useful while integrating modulus functions. Next we have integral a to b f of x dx. It is equal to integral a to b f of a plus b minus x dx. Then the fifth property is integral 0 to a f of x dx. It is equal to integral 0 to a f of a minus x dx. Next we have the next property, integral 0 to 2a f of x dx. It is equal to integral 0 to a f of x dx plus integral 0 to a f of 2a minus x dx. The next property is a continuation of this property. So here integral 0 to 2a f of x dx, it is equal to 2 times integral 0 to a f of x dx if f of 2a minus x equal to f of x, and it is equal to 0 if f of 2a minus x equal to minus f of x. So here if f of 2a minus x is equal to f of x, then this integral, it will be 2 times integral 0 to a f of x dx, and if f of 2a minus x is equal to minus f of x, then here we will have plus f of x dx, here minus f of x dx, those both will get cancelled. It is equal to 0. Next we have the next property, integral minus a to a f of x dx equal to 2 times integral 0 to a f of x dx if the function f is even, and it is equal to 0 if f is odd. Now we call a function an even function when f of minus x, it is equal to f of x. Say for example x square. If f of x is x square, then f of minus x will be minus x the whole square, which is again x square. It is equal to f of x. So here in this case, this function x square is an even function. On the other hand, if we have function say x cube, here if we take f of x as equal to x cube, then f of minus x will be minus x cube. So here f of minus x is equal to minus f of x. As a result, this function is x cube is an odd function. So if we have an integral of this form, integral minus a to a f of x dx, it will be twice integral 0 to a f of x dx if f is even, and it will be equal to 0 if f is odd. So here these are the various properties of definite integral which will be very useful in solving the problems easily. Now let us move on to the examples. Evaluate the following definite integral. So here first we have to find integral 0 to a mod x minus 2 dx. So let us take, let the given integral be I equal to integral 0 to 4 mod x minus 2 dx. So when we have a modulus function, then we can use this property, the third property, integral 0 to a f of x dx is equal to integral a to c f of x dx plus integral c to b f of x dx. The reason being, if we consider mod x minus 2 in the interval 0 to 4, from 0 to 4, here if we have say 2, then in this interval, in the interval 0 to 2, x minus 2 is negative, and in the interval 2 to 4 it is positive. So what we can do is, we can write I is equal to integral 0 to 2 mod x minus 2 dx plus integral 2 to 4 mod x minus 2 dx. That is, we equate x minus 2 to 0 and we find the critical point for this function. So here the critical point is 2, so we divide the interval from 0 to 2 and then from 2 to 4. So in the interval 0 to 2, this is negative. So this is minus integral 0 to 2 x minus 2 dx, and in the interval 2 to 4 it is positive to x minus 2 dx. Now we can integrate this. So here integral 0 to 2 x minus 2 dx is x minus 2 the whole square by 2 with the limits 0 to 2 plus x minus 2 the whole square by 2 with the limits 2 to 4. So here when we substitute the upper limit, it is 2 minus 2, 0, and when we substitute the lower limit, 0 minus 2 the whole square is 4 by 2 is 2. Plus here when we substitute the upper limit, it is 4 minus 2 the whole square, 2 square by 2, which is 2, and when we substitute the lower limit, it is 0. So this is 2 plus 2, which is equal to 4. Therefore, the value of this given integral, it is equal to 4. Now let us move on to the next subdivision, integral minus 1 to 2 mod x cube minus x dx. That is the B part. So the B subdivision, this we have already completed. So let us take, let I equal to this given integral. So here if we consider x cube minus x cube minus x, if we equate it to 0 to find the critical point, so it is x into x square minus 1 equal to 0, or we have x into x plus 1 into x minus 1 equal to 0. So we get x is equal to minus 1, 0 and 1. So on the number line we can divide this interval from minus 1 to 2 into minus 1 to 0, 0 to 1 and then 1 to 2. Now when we consider this function x cube minus x in the interval here 1 to 2, if we consider any point say 1.5 here, then the value of x cube minus x, it is positive here. Then in the interval 0 to 1, it is negative, and in the interval -1 to 0 it is positive. So the given integral, it can be written as integral -1 to 0 mod x cube minus x dx plus integral 0 to 1 mod x cube minus x dx plus integral 1 to 2 mod x cube minus x dx. So here x cube minus x is positive, so it is x cube minus x dx, plus here it is negative, so it is minus integral 0 to 1 x cube minus x dx plus integral 1 to 2 x cube minus x dx. So now we can integrate and apply the limits for each of these integrals separately. So I is equal to x raised to 4 by 4 minus x square by 2 from -1 to 0 minus x raised to 4 by 4 minus x square by 2 with the limits 0 to 1 plus x raised to 4 by 4 minus x square by 2 with the limits 1 to 2. So when we put the upper limit, it is 0 minus, when we put the lower limit, it is 1 by 4 minus half. 1 by 4 minus half minus, here when we put the upper limit, it is 1 by 4 minus half, and the lower limit is 0. Then here when we put the upper limit, it is 2 raised to 4 16 by 4 4 minus 2 square is 4 by 2 2 minus the lower limit is 1 by 4 minus half. So 1 by 4 minus half, it is 1 by 4, it is minus 1 by 4, so minus of minus 1 by 4 is plus 1 by 4, and here also minus of minus 1 by 4 is plus 1 by 4, then 4 minus 2 2, here also minus of minus 1 by 4 plus 1 by 4. So this is 2 plus 3 by 4, which is 11 by 4. Therefore the value of this integral, it is 11 by 4. Now moving on, next question, evaluate integral -1 to 1 e raised to x upon e raised to x plus e raised to minus x dx. So here we can use the property integral a to b f of x dx, it is equal to integral a to b f of a plus b minus x dx. So we can use this property. Here the lower limit a is -1 and the upper limit b is 1. So first let us take, let I equal to the given integral. Let us replace x by -1 plus 1 minus x. So it is 0 minus x, which is minus x. So here we will get e raised to minus x upon e raised to minus x plus e raised to x. It will be the same integral because of this reason. So this is equal to integral -1 to 1 e raised to minus x upon e raised to minus x plus e raised to minus of minus x is plus x. Since the reason should be written as the property, integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx. So here we can add 1 and 2. When we add 1 and 2, the left hand side will be I plus I, which is 2i. So 2i will be integral -1 to 1. The denominator is the same, that is e raised to x plus e raised to minus x. So we can add the numerators. It will be e raised to x plus e raised to minus x upon e raised to x plus e raised to minus x dx. So these two will go. we are left with integral minus 1 to 1 dx. It is x with the limits minus 1 to 1. So it is 1 plus 1, which is 2. We get 2i as 2, so I is equal to 1. Therefore, the value of this given integral is 1. Next question, evaluate integral 0 to 1 log x by log x plus log 1 minus x dx. So here let us take the given integral as I. Here we can replace. Here this is of the form integral 0 to a f of x dx. This is equal to integral 0 to a f of a minus x dx. So using this property, we can find the value of this integral easily. Replacing x by 1 minus x, we get I equal to integral 0 to 1 log 1 minus x upon log 1 minus x plus, here if we put 1 minus x in place of x, we will get log 1 minus 1 plus x. So here we will get log x dx. Again we can add 1 and 2. Adding 1 and 2. Left hand side we have I plus I 2i, and right hand side we have integral 0 to 1. Denominator is the same. It is log x plus log 1 minus x. So numerator we can add. It becomes log x plus log 1 minus x upon log x plus log 1 minus x dx. So this becomes integral 0 to 1 dx. It is x with the limits 0 to 1. So it is 1 minus 0. We get 2i as equal to 1. So I will be equal to half. So this is the value of I. Moving on to the next question, integral 1 to 3 cube root of x upon cube root of x plus cube root of 4 minus x. So here let us let the given integral be I. So here again we have to use the property that we have already seen. Replacing x by 1 plus 3 minus x, which is 4 minus x. We get I as integral 1 to 3 cube root of 4 minus x upon cube root of 4 minus x plus cube root of, here we are replacing x by 4 minus x. So it is 4 minus 4 plus x. So it is x. Again let us add 1 and 2. Left hand side becomes 2i. It is equal to integral 1 to 3. Denominator is the same, so let us add the numerators. So it is cube root of x plus cube root of 4 minus x upon cube root of x plus cube root of 4 minus x dx. So again we get integral 1 to 3 dx. So it is x with the limits 1 to 3, which is 3 minus 1, 2. So we get 2i as 2, I is equal to 1. So here this is because I forgot to write the reason. Integral a to b f of x dx, it is equal to integral a to b f of a plus b minus x dx. So we get the value of this given integral as equal to 1. And next we have in application of integration consumer surplus and producer surplus. So before seeing consumer surplus, we know what is a demand curve. It is a graphical representation of the relationship between the price of a good or service and the quantity demanded for a given period of time. So here we can see that the demand curve, it is a downward sloping curve. So here we assume that the prevailing market price is P0 and the quantity of commodity which is sold at this price, it is X0. We say a consumer surplus, it happens when the price that consumers pay for a product or service is less than the price they are willing to pay. So there are consumers who are willing to pay price which is more than the market price, which is P0. So this additional benefit which the consumers get, it is called the consumer surplus. So in this graph, consumer surplus is given by the area bounded by this region. So there are buyers who will be willing to pay a price higher than P0. These buyers will gain from the fact that the prevailing market price is only P0. So this gain, it is called the consumer surplus. So consumer surplus is the area bounded by this region. So it is nothing but the area bounded by this curve, this whole area minus the area of this rectangle, which is P0 X0. So consumer surplus, it is given by integral 0 to X0 f of x dx minus area of this rectangle, which is P0 X0. So using this relation, we can find the consumer surplus. Let us continue with examples. Find the consumer surplus for the demand function P equal to 25 minus x square when P0 is 19. So here they have given the price P0. So for this price P0, we have to find the quantity demanded X0. So let us substituting P0 equal to 19 in P equal to 25 minus x square. We get 19 equal to 25 minus x square, or we get x square plus x. Here plus 19 minus 25 is minus 6 equal to 0. So here this is x square plus 3x minus 2x minus 6 equal to 0, or we get x plus 3 into x minus 2 equal to 0. So x is minus 2, x is 2 or x is minus 3. This is not possible. That is the quantity demanded, it can't be negative. Therefore, x0 is equal to 2. Now the consumer surplus, it is given by integral 0 to x0 demand function f of x dx minus P0 x0. So it is integral 0 to 2, demand function is here 25 minus x square minus P0 is 19 and x0 is 2. So this is 25x minus x square by 2 minus x cube by 3 with the limits 0 to 2 minus 38. So this is 50 minus 2 minus 8 by 3. The lower limit is 0 minus 38. So this is 48 minus 38 is 10 minus 8 by 3. So it is 30 minus 8 by 3, which is 22 by 3. So the consumer surplus is 22 by 3 units. Next we have the next example. The demand function for a commodity is P equal to 10 by x plus 1. Find the consumer surplus when the prevailing market price is 5. So here when P0 equal to 5, we have 5 equal to 10 upon 5x x plus 1 or we have x plus 1 equal to 2, which implies x equal to 1. Therefore, x naught equal to 1. Consumer surplus is given by integral 0 to x naught, demand curve minus p naught x naught. So it is integral 0 to 1. This is the demand curve. 10 upon x plus 1 dx minus p naught is 5, x naught is 1. So this is 10 into log mod x plus 1 with the limits 0 to 1 minus 5. So this is 10 log 2 minus log 1 minus 5. Log 1 is 0. So the consumer surplus is given by 10 log 2 minus 5. So this is the consumer surplus. And next we have the producer surplus. So to understand producer surplus, first we have to understand what is the supply curve. So the supply curve is an upward sloping curve. It shows the relationship between the price of a good or service and the quantity supplied for a given period of time. So here, as the price of the given commodity increases, the quantity supplied increases. This is quantity. All other things being equal. And now let us assume that the prevailing market price is P naught, and at this price P naught, the producers are willing to offer a quantity of x naught to the buyers. So let us assume this scenario. And now we have some producers who are willing to supply the commodity at a price lower than this P naught. So all those producers, they will gain because of the fact that the prevailing market price is P naught. So this part, it is nothing but it is the producer surplus. So it is the area above the supply curve P is equal to G of x and below the line P equal to P naught. So it is the area bounded by this rectangle OPBA minus this part, this area, which is nothing but producer surplus is the area bounded by this rectangle given by P naught x naught minus integral 0 to x naught. Supply curve, it is this part. It is this whole rectangle minus the area of this part. So this is the producer surplus. Now let us see the example. The supply function for a commodity is P equal to x square plus 4x plus 5, where x denotes supply. Find the producer surplus when the price is 10. So here they have given P naught as 10. When P naught equal to 10, we have 10 equal to x square plus 4x plus 5, or x square plus 4x minus 5 equal to 0. So here we will have x square plus 5x minus x minus 5 equal to 0. As a result, we have x plus 5 into x minus 1 equal to 0. So we have x is equal to 1 or x equal to minus 5. This is not possible. Having a negative amount of commodity is not possible. Therefore, x naught equal to 1. The producer surplus, it is given by P naught x naught minus integral 0 to x naught supply curve dx. So here P naught is 10, x naught is 1 minus integral 0 to 1. This is the supply curve. X square plus 4x plus 5 dx. So this is 10 minus x cube by 3 plus 4x square by 2 plus 5x with the limits 0 to 1. So this is 10 minus the upper limit is 1 by 3 plus 2 plus 5 minus lower limit is 0. So this is 10 minus 7, which is 3, 3 minus 1 by 3. So it is 8 by 3. Therefore, producer surplus equal to 8 by 3 units. So this is with respect to consumer surplus and producer surplus. Next, moving on to the last topic, which is equilibrium price and quantity. The equilibrium price is the price where the amount of the product that consumers want to buy is equal to the amount producers want to sell. That is, the quantity demanded is equal to the quantity supplied. So here we can see that this is the demand curve and this is the supply curve. The point of intersection of the demand curve and the supply curve will give us the point of equilibrium. So at this point we can find the equilibrium quantity demanded and the corresponding price will give the equilibrium price. Now we have an example. Suppose that demand is given by the equation xd equal to 500 minus 50p, where xd is the quantity demanded and p is the price of the good, and supply is given by xs is equal to 50 plus 25p, where xs is the quantity supplied. What is the equilibrium price and quantity? Now we know at equilibrium, we just now saw the quantity supplied is equal to the quantity demanded, that is xd equal to xs. So this is the quantity demanded and this is the quantity supplied. At equilibrium, these two are equal. So from this we get 500 minus 50p equal to 50 plus 25p. So 500 minus 50, 450 equal to 50 plus 25, 75p. So from this we get p is equal to 450 by 75, which is 6. So the equilibrium price is 6. Equilibrium quantity we can substitute in any of these and find. Therefore PE, which is equilibrium quantity, it is rupees 6. And equilibrium quantity will be 500 minus 50 into 6. So it is 500 minus 300, which is 200. Therefore equilibrium quantity is 200 units. So this is the equilibrium price and this is the equilibrium quantity. So these are the various concepts and topics we have in integration and its applications. I hope this video was useful for you. If you have not subscribed to my channel, please subscribe. If you find this video useful, share it with your friends. Thank you for watching.